So let's find the interval of convergence for our power series here. It's showing. So yeah, step one is our ratio test. The limit as n goes to infinity. Absolute value of a sub n plus 1 divided by a sub n. So that is, in this case, the n plus 1 term, we would have n plus 1 times x plus 3 to the n plus 1 divided by 5 to the n plus 1. That would be the a sub n plus 1. Now it's divided by a sub n, which that's just going to mean times it by the reciprocal of this, so that would be 5 to the n over n times x plus 3 to the n. And in this particular case, there's no alternating sign, so nothing really changes there about that. But let's see what we get as far as cancellation here. What are we going to be able to cancel out? Well, looks like we've got x plus 3 to the n plus 1, so that'd be x plus 3 to the n times x plus 3 to the 1. And that'll cancel nicely out, a little bit of that. And then the 5 to the n plus 1 would be 5 to the n times 5 to the 1, and that'll cancel out nicely with over here as well. So I believe what I'm seeing is that's gone and that's gone. If I get now the n's together, so I'd have n plus 1 over, let's put the 5 in here too. Put the n's together. Now the x's, well, it's all that's left is that x plus 3 first. So n goes to infinity, what is this going to go to? Looks like one-fifth times x plus 3. So it looks like by ratio test I need that less than 1. Yeah, I need that less than 1. You know, we could do the -1 to +1 thing here. We could multiply both sides by 5. Doesn't matter to me, but in either case, we're going to get -5 is less than x plus 3 is less than 5, right? So it looks like -8 to +2 is my start, my interval. The only thing I have to check from there is the endpoints. So here's one where the endpoints are not -1, they're -8 to +2. All right, so x is -8. What do we got? Well, you go back to the series and plug in x to be -8. So that would be n times -5 to the n over 5 to the n. Oh, hey, look at that. So I could say that's n times -1 to the n times 5 to the n. And that just gets me down to n times -1 to the n. What kind of series you got there? It's alternating, but what test would apply here? It's test by emergence, isn't it?
Yeah.
The a sub n is not going to be 0. That a sub n, the limit as in a sub n, the limit as n goes to infinity, the a sub n's would be the limit of n times -1 to the n. That's certainly not going to be 0. It's infinity, isn't it? Well, it'd be, part of it would be infinity, part of it would be negative infinity, because it's alternating signs. Part of it would go to infinity and part of it would go to negative infinity. You with me there? So this doesn't exist. So yeah, that's definitely divergent. All right, let's see what happens when x, what's the other endpoint, 2? So check x equals 2, so plug in x to be 2 there. So we have n times 5 to the n over 5 to the n. That's definitely divergent, isn't it? My test for divergence. And one of the things, again, I'm looking for on these is what test you're using. Not just taking a guess in the dark. Tell me what test you're using. So neither of the endpoints work here. Both are divergent. So the interval of convergence is just right there. IOC. Negative 8 to 2, neither of the endpoints. I think they use those that mostly for their answers. Is that okay? All right, now another just have another term, I guess you might call it. It's called the radius of convergence. So to go along with the interval of convergence, we have the radius of convergence. And a good example to use to give you the radius of convergence is let's use this one. All right, so let's say we've got the interval is negative 8, positive 2. Okay, so let's think about that on the number line here. So I'm going from negative 8 to positive 2. Talking about that interval there, as far as the x's are concerned. Well, the radius of convergence, if we take a look here, there's a midpoint in that interval. The radius of convergence is the distance from the midpoint out to an endpoint. That's R for radius of convergence. It's just from the midpoint out to an endpoint. That's the radius of convergence, which in this case is going to be 5. The radius of convergence is 5. So that the radius of convergence is just the distance from the midpoint to the endpoint, to an endpoint. Because it's 5 either way. That's the radius of convergence. Call it R. Now, what we might note here, and that's why I did back on this one. Do you notice 5's involved in that little thing right there? Right there's your radius. If you get this inequality, this absolute value inequality to like this, where you have x plus a number less than a number, or whatever. I mean, I guess it's actually this probably. It doesn't matter in either case. If you have x plus a number, x minus a number, this number right here, that's going to be your radius of convergence. And the other alternative is just the absolute, if you don't have the shift on. Oops. All three of those cases. Yeah, if you get it to absolute value of x is less than a number, that's going to be also your radius of convergence. It's a little easier, because this one you don't have, it's shifted. You're just going between negative b and positive b, and that's obviously going to be your radius of convergence, right?
So is it just once it looks like whatever was in your original deal?
Yeah, see, this one started out, that was the inequality I started with, right?
Yeah.
So I multiplied by 5 and I got it to this form. That's the form you can read the radius of convergence off of. Because if we just started there, we got a 1 over here. That's not the radius of convergence. It's when you have it in this form. The absolute value of x plus a number, x minus a number. If you got it in that form, that's when you can tell your radius of convergence off of that. I mean, otherwise, you just have to figure out, well, negative 8 to 2, the midpoint's, what? I don't even know what the midpoint would be.
-3.
Negative 3. It's negative 3, yeah. Well, that's where 3 comes in. In both cases, it's 5 units away. So, but that's what it's called. So yeah, the radius of convergence on these is a whole lot easier because it's not shifted. But if you've got it in this form, it's not that bad either. So, if it asks for the radius of convergence, so besides this one, the two we had was -1 to 1. That was the interval of convergence, or I think we had one of these. In all three of those cases, what's the radius of convergence? It's 1, yeah. Yeah, because your midpoint's 0, so it's the radius of convergence is 1. So anyway,
So
that's
that's fractions for the R. Well,
could have fractions, yeah. Could have fractions. I mean, if it was like if I had 5 times the absolute value of x minus 2 less than 1. Say that's what I came up with from my ratio test. Well, in this case, I divide by 5, right? And so x minus 2, the absolute value is less than 1/5. So that's going to be your radius of convergence there. So yeah, it's very possible to have a radius of convergence that's less than 1. Possible. Anything else?